Hey guys, it's Group 8 here, and we're going to give you a review on Chapter 6, which is on chemical bonding. Now, please pay attention as we will address and cover some topics, because some review questions will be at the end of certain slides. Now, let's frickin' go! Section 1, Types of Chemical Bonding. As you already know, or should already know, all matter is made up of atoms, but atoms in the universe are rarely found hanging out by themselves. They are most commonly found combined with other atoms through chemical bonds. Now you may find yourself asking, damn Carrington, what's a chemical bond? I hella forgot. Shame on you. Well, a chemical bond is like glue that holds atoms or molecules together. It is caused by electrical attraction that occurs between the nuclei and valence electrons of different atoms, hence binding them together. Now there are two main types of chemical bonding, ionic and covalent. Ionic bonds are the result of electrons being transferred between two atoms. This is due to an electrical attraction between anions and cations. Remember, anions are negatively charged ions and cations are positively charged ions. Covalent bonds are the result of electrons shared between atoms. They can be classified as either polar covalent or nonpolar covalent. Polar covalent bonds share the electrons unequally due to the electronegativity differences. This results in a molecule with a slightly positive part and a slightly negative part. Nonpolar covalent bonds share electrons equally, so they have a balanced charge. It's pretty simple, right? Moving on to how to classify bonding. Now there are many ways to classify bonding, but there are 4 rules of classification that must always be followed if using electronegativity differences. First, you need to determine the electronegativity of each atom, then find the difference. Now the 4 rules are: 1. If the electronegativity difference is less than 0.5, then the bond is considered nonpolar covalent. 2. If the electronegativity difference is between 0.5 and 1.6, then the bond is now a polar covalent. 3. If the electronegativity difference is greater than 2.0, then it is an ionic bond. And 4. If the electronegativity is between 1.6 and 2.0, and if a metal is involved, then the bond is ionic. If only nonmetals are involved, then the bond is polar covalent. Now looking at this picture on the right, we can tell that there are 2 types of classifications. There's the intramolecular bonding on the left, which is a force of attraction within the molecule, and it determines the chemical properties. And on the right, we have the intermolecular bonding, which is the force of attraction between 2 or more molecules, and that determines the physical properties of ionic and covalent bonds. Section 2, Molecular Compounds. What is a molecule? A molecule is a group of atoms that are neutral and held together by covalent bonds. And don't worry, we'll go more in depth of covalent bonds in the next slide. Now, a molecular compound is a chemical compound whose simplest units are molecules. Remember that these will always contain 2 nonmetals because the bonding does not involve ions, which would make it an ionic compound. A chemical formula tells and makes up the compound, and it explains the number of atoms in a chemical compound and uses atomic symbols to represent each element. An example of a chemical formula is a molecular formula, which is a chemical formula of a molecular compound, and it shows types and numbers of atoms combined in a single molecule of a molecular compound, and tells what kind of atoms and how many atoms are combined in each compound. For example, H2O. This indicates that there are 2 hydrogen atoms and 1 oxygen atom joined together by covalent bonds. The chemical formula can be seen as a foundation of a molecular formula. Now there are also diatomic molecules, which is a molecule containing 2 atoms due to the prefix di, such as O2. Now review! If I told you that a compound like, tegamium or something contained 2 carbon atoms, 3 hydrogen atoms, and 2 oxygen atoms, in that order write the chemical formula. You should get C2H3O2. Now another question. H2O, okay, I want you to fill in the blanks. H2O is an example of a blank compound because it contains 2 blanks. And the atoms, do they combine covalently or ionically? You should get that H2O is an example of a molecular compound because it contains 2 nonmetals and the atoms combine covalently. The formation of covalent bonds. It's actually pretty simple. Basically, if there are two atoms that are separated by a large distance, then their potential energy is set at 0. Think of it as like a guy who lives in like California or something, and he sees a cute girl on Instagram and finds out she lives in Vermont, because nobody freaking lives in Vermont. Anyways, what would happen if one atom decided to approach the other? That's like the girl getting a plane ticket saying, hey, I'm going to see you tonight out there in Cali. Anyways, he's about to get catfished, but because the atoms will contain positively charged protons, and because their nucleus is surrounded by negatively charged electrons, as they approach each other, they will begin to interact with each other. Hashtag Area 5. As they approach and interact, their potential energy decreases, however. While this is happening, the two nuclei repel one another and the electrons do the same, which results in an increase in potential energy. Eventually, these atoms will form a covalent bond. So remember, attraction between particles produces a decrease in potential energy, while repulsion in particles produces an increase in potential energy. This is literally saying that opposites attract. When forming a covalent bond, the atoms will release energy as they go from individual atoms to parts of a molecule, and the amount of energy released is the difference between the energy at the separated atoms and at that of the bonded atoms. Keep in mind that the same amount of energy is needed to separate these bonded atoms, and the bond energy is the term for the energy required to break a chemical bond and form neutral atoms. Now we have the octet rule, the E dot notation, which is the electron dot notation, and Lewis structures. We know that the octet rule requires all atoms in a molecule to have 8 valence electrons because it wants to get a full outer shell of the nearest noble gas. And since noble gases have 8 valence electrons, they are very stable. Following the octet rule results in completely filled s and p orbitals in an atom's outermost energy level. We also know that shells are electrons that surround the core of every atom, and the outermost shell, which we know are the valence electrons, and they are most important and most commonly referred to because they are the ones that hold the electrons that take part in chemical reactions. If that shell is full, the atom generally doesn't react with others, but however, if it is partially full, then it will react with others in order to create molecules. Think of Julius, and he just had 4 burgers from In-N-Out. If I ask, hey, do you want to go to Five Guys? He'll be like, no, nah, bruh, I'm hella full. I just have 4 burgers, fam. And then he'd go home and probably be in the bathroom for a long time. Anyways, this is like a full outer shell which won't really react with other atoms. On the other hand, if Julius only had a chip and a Capri Sun and he's asked to get food, he'll be like, hell yeah, bro, I'm hungry AF, let's go. This is similar to a partially full outer shell. It will react with others in order to become full, which will make molecules. Now, the process of covalent bonding usually involves the valence electrons of an atom, and the electron dot notation makes it easier and simple to keep track of these electrons, and the notation is easy to write and understand. The picture on the bottom represents the E dot notation of chlorine and carbon. Chlorine is represented in the 17th group on the periodic table, and that is why it has 7 valence electrons. And you see that one unpaired electron? Yeah, he's 7th wheeling. Anyways, carbon has 4 valence electrons, and neither of them are paired. We also have a Lewis structure, which is a formula which shows the atomic symbol, covalent bonds, and unshared electrons. And the picture on the top represents the Lewis structure. Now, as a review, the octet rule wants to become stable by having blank number of valence electrons. You should get 8. And this is true or false. The E dot notation also represents the number of protons because a neutral atom contains the same number of protons and electrons. And you should get false. If you get true, Ionic compounds. Look at that beautiful ionic bond on the right. Anyways, what we have next are ionic compounds. Earlier we said that ionic bonds are the result of atoms transferring electrons. Do you remember that? Well, we all know that opposites attract, right? This is the case for ionic compounds. They are formed when cations and anions attract each other and then give or take electrons. The negative and positive charges create a bond that holds these two atoms together. They do this to try to fill up their outer valence shell, and when this occurs, the compound is neutral due to the opposite charges canceling each other out. The formula unit is used to establish an ionic compound's formula. It shows the simplest grouping of atoms that can be used to determine the formula. An example of this is NaCl, a sodium cation and a chloride anion. Ionic bonding has its own special characteristics. They typically have high melting and boiling points, which make them hard and brittle, and they also form lattice or crystalline structures to minimize potential energy. Now, since we've been talking about different types of compounds, let's look at the difference between ionic and molecular compounds. First, let's start off with ionic compounds on the left. These compounds are made up of metals and nonmetals. They are organized in lattice structures. To form bonds, these atoms steal electrons due to attraction of opposite charges, hence they are composed of ions. They have high melting and boiling points, which is due to these bonds being very strong. They also are conductors of electricity, even when melted. But what about molecular compounds? On the right, we can tell that these compounds are only made up of nonmetals. They are formed when electron pairs are shared between two atoms, and these compounds exist in molecules such as gases, liquids, or solids. They aren't as strong as ionic compounds, so they have low melting and boiling points, and they also happen to be poor conductors of electricity. How are they similar? Well, both nonmetals are in them, and both compounds are formed by the atoms trying to achieve a state of 8 or 2 electrons in their valence, which is their outer shell. Section 4, metallic bonding. We're almost done. If you look at the highest energy levels of most metal atoms, you will observe that they are occupied by very few electrons. In a metal, the vacant orbitals in the atom's outer energy levels overlap, and because of this, the outer electrons of the atom are able to roam freely throughout the metal. Then the electrons are delocalized, which means that the electrons don't belong to any one atom and can move freely. Then they form a sea of electrons, and the chemical bonding that results from the attraction between metal atoms and the surrounding sea of electrons is called metallic bonding. Metals bond to nonmetals most commonly through ionic bonding. This is where the metal loses an electron to the nonmetal, causing the metal to become positively charged and the nonmetal to become negatively charged. They are then strongly attracted to each other, which causes the compound to display different chemical properties like high boiling point or melting point. Metals are also strong absorbers and reflectors of light and can also absorb a wide range of light frequencies. The metallic bond accounts for many physical characteristics of metals such as strength, malleability, ductility, luster, conduction of heat, and electricity. Most metals can easily be formed into any shape desired due to their malleability and ductility. What is malleability and ductility? Well, malleability is the ability of a substance to be hammered down or beaten into thin sheets, sort of like pancakes. Ductility is the ability of a substance to be drawn, pulled, or extruded through a small opening to produce wire.
Hi, it's Mr. Tan here, and today we're going to be talking about
molecular geometry.
So what is?
Molecular geometry.
Basically, it's just the 3D shape of a molecule. We can predict the shapes using two theories, VSEPR theory and the hybridization theory. But for now, let's focus on the VSEPR theory. VSEPR stands for valence shell electron pair repulsion. I know what you're thinking, valence shell what? But it's basically saying that valence electron pairs have repulsion, causing them to be located as far away from each other as possible. Using this, we can estimate the shape of the molecule. Just imagine two people who are both stubborn. If you put them in the same group, they will clash. Hence, they need to be separated with the maximum distance between them as possible. It's the same with electrons. They also need to be separated with the maximum distance possible. This is easy when you have an even number of electrons that are all shared. But when you have some electrons that are not shared, things are a bit different. According to the VSEPR theory, we also account for those unshared pairs in our model. Those unshared pairs occupy space, but are not illustrated in the actual molecule shape. This will cause the molecule to be bent. This may be all confusing, but a simple way to predict the shape of a molecule using VSEPR can be summed down to a simple equation. Sn, or steric number, equals the number of bonded atoms to the central atom and the number of lone pairs to the central atom. To determine these numbers, just draw a molecule using the Lewis dot diagram structure. Then, depending on the Sn number, you can determine the shape according to the chart above. Try predicting the shape of a chloride ion, ClO3 molecule. Look at the Lewis dot structure. We can see that there are 3 atoms bonded to the lone pair of electrons. 3 plus 1 equals 4. This atom has a tetrahedral shape with 3 oxygen atoms at the bottom 3 corners and a lone electron on the top. If you don't understand that, don't worry. I did not understand any of this too. Next, let's look at hybridization. This is a model that shows the orbital rearrangements after the formation of a covalent bond. Hopefully, you remember stuff about atomic orbitals. If not, that's too bad. Basically, we just want to covalently bond equally with whatever molecule you bond to. An example of this is with methane, CH4. The carbon has 4 valence electrons, while hydrogen only has 1. It must hybridize the 2s and 2p sublevels to create a new orbital, the sp3 sublevel. To do this, you have to move the electrons from the 2s sublevel to the 2p sublevel. If you don't understand what I just said, basically, it's just like having 4 wolves, and the only way they will look at you is by giving them food. You have a box that contains 2 cookies, and 2 boxes with 1 cookie. You only have 3 boxes in total, so you must open the first box that contains 2 cookies and split it. Now you have 4 cookies in total, and you can feed your wolves. And now you're happy because they get to look at you. A simple way to determine hybridization of an atom is similar to that of VSEPR theory. Determine how many atoms are connected to the central atom and how many lone pairs it has. If the number is 2, then it is sp. If the number is 3, then sp2. If it's 4, then it's sp3. If you were to have 5 groups, then your hybridization would be sp3d. Lastly, we have intermolecular forces, which is the force of attraction and repulsion between molecules. A good way to remember this is if you have studied Greek, the root inter means between. So study your Greek, kids. Polar molecules generally have the strongest intermolecular forces because they possess a positive and negative charge, which we call a dipole. The dipole-dipole interaction is just when a charge from a molecule is attracted to the oppositely charged molecule. Hydrogen bonds is a form of intermolecular forces. These bonds are formed by attractions due to polar molecules having a partial negative and positive charge. The positive and negative regions cause attractions with other molecules with opposite charges. Since hydrogen is just a positive charged proton, it will bond directly with the most electronegative molecule. An example of this is with a water molecule. The dotted line shows the hydrogen is bonding to another oxygen atom that is not in its own makeup. London dispersion forces are found in all molecules. It is caused from uneven distribution of electrons, which cause a temporary dipole. Without these forces, we wouldn't be able to have noble gases in a liquid state. If we take a look at 2 helium molecules, the negative charged electrons from one helium molecule is attracted to the positive charged protons within the other. It will cause a migration of one helium's electrons because the closer the heliums get to each other, the larger the repulsion between electrons. This is why it creates a temporary dipole. The electrons and the protons are now on opposite ends of each other. So the London dispersion force is the connection that holds the 2 dipoles together. Now that you know the basics of chemical bonding, let's try some review questions. First question: what is the difference between ionic and covalent bonds? Time's up. Remember, ionic bonds form when atoms gain or lose electrons to the atom it bonds to. Covalent bonds form when electrons are shared between atoms. Next question: why are metals good conductors of electricity? Time's up. Electricity is defined as the flow of electrons. Metal atoms have electrons that can move freely around, hence making it a good conductor of electricity. Okay, last but not least, what does the VSEPR theory state? Time's up. The theory states that valence electrons have repulsion and always want to have as much distance between them as possible. If you don't remember this, just think of 2 stubborn people who can't work together, and they need their distance. If you aren't able to answer these questions, you probably need more practice on this. But don't worry, many other fine young students have made PowerPoints on this section. So go check them out. Or you could just replay this PowerPoint. So yeah, that was chemical bonding, and I hope that was helpful.